Right. Let's look at question number 2 in applied paper. So this is the projectile question. A bomb B is released from an aeroplane which is flying horizontally with velocity u and at a constant height h. When it is released from rest, and at the same time a bullet A is fired from point which is vertically below the aeroplane. It is given that bullet is fired at an angle theta to the horizontal to blast the bomb after time t, and we have to show that time t is equal to this expression, right? So let's draw a small sketch. So aeroplane is going and a bomb is released. So aeroplane is going at a height h, constant height of h, and released, right? Aeroplane is going horizontally, so we have what? V aeroplane relative to earth is what? U in this direction. V bomb relative to plane is what? 0, no? Then V bomb relative to earth is what? That's going to be also U, using the relationship for relative velocities. We get okay, aeroplane is P, no? I put A here. This is plane's velocity relative to earth, which is U, right? Plane relative to earth. So then that is also going to be U. So bomb's velocity relative to earth is also U in horizontal direction, right? We figured that out. Now that is bomb, and another bullet is fired from a point exactly vertically below that point, which is bullet A, at an angle theta to the horizontal. The speed is not given, we'll mark it as V, and what will happen? They will go like this, and at some point they will collide, right? That time is also given. They will collide at time t, right? So when they collide, both of them have gone the same horizontal distance. Vertical distance are different. Bullet A h1 and the bomb h2. What's the relationship between h1 and h2? When you add them, it has to be equal to that height h, right? So this is this is how the diagram looks, right? Now we have to find simple t. So apply what? S equals ut for both of them, and s equals ut plus half a t squared to both of them. Using those 4 equations, you should be able to get the answer. So first I will do for bomb s equals ut, so horizontally, so it will be s equals just ut, no? Right? So that's the first equation. Then for the bullet A, same thing, horizontal motion, s equals ut. What do you get? Again, this horizontal distance when they collide is the same. Now this one, what is the velocity component? V cos theta. Horizontal component is V cos theta times t. Then from here, let's mark it as number 2. Then what can you do? Equal first equation with second equation, same displacement. So ut is equal to V cos theta t. So then we can find the expression for the speed of the bullet or the velocity of the bullet, v cos theta equals u, or v equals u over cos theta, right? Let's mark it as equation 3. Then we'll apply s equals ut plus half at squared for both of them, bullet and the bomb. So for the bomb, we'll take down as positive because it's going down. So then distance is h2, displacement h2. There's no vertical component. Vertical velocity at the beginning is 0. So ut is 0, half g t squared. Right. So let's mark it as fourth equation. Then for A, the bullet s equals ut plus half at squared, up. It's going up now. So then displacement we are measuring from ground. So h1, this has a vertical velocity at the beginning. So v sine theta time is t minus half gt squared. Why? Because acceleration is negative when you are applying it up, right? So then what can we do? Add the two equation 4 plus 5. So you get what? h1 plus h2, the gt squares cancel, you get v sine theta t here. What is h1 and h2 together? That is h, this distance. So you get h v sine theta t. So then sub 3 into 6. So you will get h. What is v? V is u cos theta sine theta t subject t. So you get what? H. You can move the cos theta to this side. H cos theta over u sine theta equals t. So then t is equal to what? H over u cot theta, which is what we want, right? Yes, so that's the time, right? So that is the projectile question. So basically apply the two equations for the horizontal motion and vertical motion, then simplify until you get the expression, right? Okay, next we'll look at question number 3.